addressing the situation where a subpanel is currently fed from the line side of a Trilliant panel, creating a potential overload issue, and exploring solutions to rectify this before house sale. The core challenge lies in the existing electrical setup, where a square D subpanel is tapped directly from the line side of the main Trilliant panel, effectively bypassing the main breaker. This configuration allows the house to draw significantly more current than the main service is rated for, potentially up to 300 amps in the described scenario, even though the main panel is only rated for 200 amps. Now, the problem is the home inspector flagged it, and the new homeowners are requiring a correction before finalizing the sale. The proposed solution of simply placing the subpanel on a 100 amp breaker within the Trilliant panel presents a new set of problems. While it addresses the immediate safety concern by limiting the subpanel's draw, it also reduces the overall available amperage for the house, potentially leading to more frequent breaker tripping. As you mentioned, breakers are already tripping. This is because the house's electrical load is already close to the existing capacity. Therefore, a service upgrade to 300 amps seems like the most appropriate long-term solution. This would provide ample capacity for the existing load in the subpanel, ensuring safe and reliable operation of the electrical system. However, service upgrades can be expensive and time-consuming, often involving permits, utility company coordination, and significant rewiring. Given the homeowner's likely preference for the cheapest and fastest solution to satisfy the home inspection requirements, they may lean towards replacing the Trilliant panel while keeping the existing 200 amp service. The most immediate concern to address is the subpanel being fed from the line side of the Trilliant panel. This is a code violation and a significant safety hazard. Rectifying this is not optional, it must be corrected. The option of replacing the Trilliant panel, while seemingly a quick fix, might not solve the underlying issue of insufficient electrical capacity and may lead to frequent breaker tripping. Replacing the panel with a similar 200 amp panel and properly connecting the subpanel through a breaker will address the immediate safety concern, but the existing load is already causing breakers to trip. This suggests the home may need more than the 200 amp panel can supply. Before committing to any solution, it's crucial to perform a thorough load calculation. This involves adding up the amperage requirements of all the appliances, lighting, and other electrical devices in the house, taking into account any diversity factors which allow for the fact that not all devices will be operating at full load simultaneously. A proper load calculation will reveal the actual electrical demand of the house and determine whether a 200 amp service is truly sufficient or if a 300 amp or larger service is necessary. Also, consider the existing square D subpanel. Determine its ampacity rating, number of circuits, and overall condition. Verify that it's properly grounded and bonded and that all connections are tight and secure. If the subpanel is old or undersized, it may be prudent to replace it with a larger, more modern subpanel to accommodate future electrical needs. When selecting a breaker for the subpanel, ensure that it is properly sized for the subpanel's ampacity and the load it will be serving. Also, verify that the breaker is compatible with the Trilliant panel. The fact that you are searching for a 100 amp 2-pole breaker suggests that the subpanel is intended to carry a significant load. The rarity of the 100 amp 2-pole Trilliant breaker indicates that these panels are not commonly used in residential applications. Before investing significant resources in locating this breaker, consider whether there are alternative solutions that would be more cost-effective and readily available. For example, could the subpanel be fed from a different location in the house, where a standard breaker can be used? Or, could the load on the subpanel be reduced by moving some of the circuits to other locations in the house? It's important to be aware of the potential safety hazards associated with electrical work. Electrical panels and wiring can be dangerous, and it's crucial to take all necessary precautions to avoid electric shock or fire. Always turn off the power to the circuit you're working on before starting any work, and use properly insulated tools. If you're not comfortable working with electricity, it's best to hire a qualified electrician to do the job. Moreover, ensure that all work complies with the National Electrical Code, or NEC, and any applicable local codes and regulations. The NEC provides detailed requirements for electrical installations, including wire sizing, overcurrent protection, grounding, and bonding. Adhering to these requirements is essential for ensuring the safety and reliability of the electrical system. Some relevant NEC articles to consider include Article 210, which covers branch circuits, Article 215, which covers feeders, Article 220, which covers load calculations, Article 230, which covers service entrances, Article 250, which covers grounding and bonding, and Article 408, which covers panel boards. To elaborate on load calculations, Article 220 provides detailed instructions on how to calculate the electrical demand of a building. This involves adding up the loads of all the individual circuits, taking into account demand factors and other adjustments. For dwelling units, the NEC specifies different methods for calculating the general lighting load, appliance load, and heating and air conditioning load. For example, the general lighting load is typically calculated at 3 volt-amps per square foot, while the small appliance load is calculated at 1500 volt-amps for each 20 amp small appliance circuit. The NEC also provides demand factors for various types of loads, which allow for the fact that not all loads will be operating at full capacity simultaneously. For example, the demand factor for the first 3000 volt-amps of general lighting load is 100%, while the demand factor for the remaining load is 35%. Once the total calculated load is determined, it can be compared to the ampacity of the service entrance conductors and the main breaker to ensure that the electrical system is adequately sized. Regarding service upgrades, increasing the service capacity from 200 amps to 300 amps involves several steps. Firstly, a permit must be obtained from the local building department. Secondly, the utility company must be notified to arrange for a service upgrade. Thirdly, the existing service entrance conductors and main breaker must be replaced with larger ones. Fourthly, the grounding and bonding system must be upgraded to comply with the new service capacity. Fifthly, the electrical panel may need to be replaced with a larger one to accommodate the additional circuits. Sixthly, all work must be inspected by the building department to ensure compliance with the NEC and local codes. Now consider the option of using a different type of breaker in the Trilliant panel. While finding a 100 amp 2-pole Trilliant breaker may be difficult, it may be possible to use a different type of breaker with an adapter or modification. However, it's important to verify that any such modification is approved by the manufacturer of the panel and complies with all applicable codes and regulations. Using an unapproved modification could void the panel's warranty and create a safety hazard. Also, consider the condition of the existing Trilliant panel. If the panel is old or damaged, it may be prudent to replace it regardless of whether a 100 amp 2-pole breaker can be found. Old panels can have deteriorated insulation, loose connections, and other problems that can create a fire hazard. Replacing the panel with a new one will improve the safety and reliability of the electrical system. Also, it's important to document all work that is performed on the electrical system. This includes creating a wiring diagram, labeling all circuits, and keeping records of all inspections and permits. Proper documentation will make it easier to troubleshoot problems in the future and will be helpful when selling the house. Considering that you are familiar with electrical systems and possess most of the required materials, it would be highly beneficial to perform a comprehensive inspection of the entire electrical system. This inspection should include checking all wiring connections for tightness, inspecting the condition of all breakers and receptacles, and testing the operation of all ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or FCIs. Any deficiencies that are found should be corrected immediately. Also, it's important to educate the homeowner about the importance of electrical safety. This includes advising them not to overload circuits, not to use extension cords as permanent wiring, and to have the electrical system inspected periodically by a qualified electrician. Educating the homeowner will help to prevent future electrical problems and ensure the safety of the occupants. When discussing the options with the homeowner, present the pros and cons of each solution in a clear and concise manner. Explain the costs, benefits, and risks associated with each option, and allow the homeowner to make an informed decision. Ultimately, The decision of how to proceed rests with the homeowner, but it's important to provide them with the information they need to make a responsible choice. Consider the long-term implications of each decision. While the cheapest option may seem attractive in the short term, it may not be the best solution in the long run. A service upgrade, while more expensive upfront, may provide greater value and peace of mind in the long term. Focus on ensuring the safety and reliability of the electrical system. Electrical safety is paramount, and it's essential to prioritize safety over cost. A properly designed and installed electrical system will provide years of trouble-free service and protect the occupants from electrical hazards. NEC Table 310.15b16 details the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius. Make sure you are using the correct gauge of wire for your 100 amp breaker. As an example, a copper 100 amp conductor rated for 75 degrees Celsius requires a 3 American wire gauge, or AUG wire. The same 100 amp conductor at 90 degrees Celsius requires a 4 AWG wire. Always consult the table to ensure you have the correct wire gauge for your breaker. In summary, this situation involves a complex electrical issue requiring careful consideration of safety, code compliance, and cost effectiveness. A thorough assessment of the existing electrical system, a detailed load calculation, and a clear understanding of the available options are essential for arriving at the best solution. By prioritizing safety and providing the homeowner with the information they need to make an informed decision, you can help to resolve this electrical problem and ensure the safety and well-being of the occupants. Replacing the panel with the same amperage rating does not eliminate the possibility of breakers tripping. A new panel may have better breakers, but if the home is drawing more than 200 amps, then breakers will still trip. A more modern subpanel would certainly be an upgrade, provided that it is correctly rated for the load it supplies. It is very important for the bus bars inside of the panel to be correctly rated to handle the load, and the panel itself must be large enough to contain all of the circuits that are needed. Breakers trip because they are designed to protect the wiring. If breakers are tripping, then they are doing what they are supposed to do. The solution is to reduce the load by either moving circuits or upgrading the panel. The homeowner might not think that the price is worth the safety of his home, which is a problem that you might encounter. Explain to the homeowner that if a breaker fails to trip, it is possible for the wiring to get hot enough to cause a fire. Many fires are caused by electrical faults, so the homeowner should consider the price of a new panel compared to the price of the entire home if it burns down. As a temporary fix, it is possible to replace the breakers with higher amp breakers. This is very dangerous because the wiring is rated for a certain amperage. This is especially true in older homes. For example, older homes might use a 14 AWG wire for a 20 amp circuit. This is incorrect. 14 AWG wire is only rated for 15 amps. The previous homeowner might have changed the breaker to 20 amps because they were constantly tripping the 15 amp breaker. This is a fire hazard, so do not use higher amp breakers as a solution. You should never increase the breaker ampacity beyond what is allowed for the lowest rated component in the circuit. The lowest rated component in the circuit is generally the wire size. If the home inspector saw that the subpanel was connected to the line side of the main panel, then he would likely also write up any other code violations that he might find. Correcting all of these code violations might be a good start to improving the electrical system in the house. If the homeowner is set on keeping the existing electrical service, then the loads will have to be reduced. Some loads can be moved to other circuits. For example, if the subpanel is dedicated to a workshop, then it can be changed to only power the lights. All of the tools could then be plugged into a normal wall outlet. This way, the subpanel is not constantly drawing high amounts of current. Another load reduction technique is to install more energy-efficient devices. LED are much more efficient than incandescent lights, so replacing the bulbs is a good first step. Another high-load device is the water heater. Water heaters consume a lot of power to heat up the water. Reducing the temperature of the water heater can help reduce the power consumption. Also, making sure the water heater is insulated is very important to prevent heat loss. One final point is that electrical distribution equipment, which includes breakers and panels, has a limited lifespan. The equipment should be inspected and maintained. Replacing old breakers is generally a good idea, because they can degrade over time and become less effective. It is recommended to consult with a qualified electrician to select the right replacement breakers for the panel. It is also possible that the breakers are tripping because they are old. It is recommended to replace breakers every 10 to 20 years. If the breakers are original to the panel, then this is a good reason to replace the breakers. A full electrical system upgrade is the best solution to this problem. A full electrical system upgrade will ensure that the house is safe and up to code. The homeowner should consider the long-term benefits of a full electrical system upgrade. There is also the possibility of connecting to solar panels, which could help reduce the load in the electrical system. The new homeowner might want to install solar panels, so it is important to consider this when upgrading the electrical system.